Today we're starting our Chapter 6 notes packet. We're on page 1. Chapter 6 is Sequences in Series. A sequence is a set of numbers written in a given order. For example, we have 1, 2, 4, 8, 16, 32. Each number in a sequence is called a term. In the above example, the first term is 1. This is our first term. Our second term is 2. Our third term is 4. Our fourth term is 8. Our fifth term is 16. And our sixth term would be 32. Right. So the third term is 4. The sixth term, or the last term, is 32. The terms of a sequence are denoted as a sub n. N represents the number of the term, the nth term. In the above example, a sub 1, or the first term, is 1. A sub 2, or the second term, is 2. A sub 3, the third term, is 4. A sub 4, the fourth term, is 8. A sub 5, or fifth term, is 16. A sub 6, or sixth term, is 32. Finite sequences contain a last term. Infinite sequences continue without ending. The above example is a finite sequence. An infinite sequence has ... after the last written term. For example, 3, 6, 9, 12, 15, 18, ... is an infinite sequence. To write the terms of the sequence, start with n equals 1 in the given rule, or sometimes known as the explicit formula, and continue until you've written the terms asked for. To use a graphing calculator to list the terms of an explicit sequence, you put the formula in y equals and look at the table of values. The x value represents n, the y value represents the value of a sub n. So, working out together, writing terms of sequences. Write the first 5 terms of the sequence. Numbers 1, 2, and 3 here have explicit formulas. Okay, so a sub n equals 5n minus 3. So a sub 1, our first term, would equal 5 times 1 minus 3. 5 times 1 is 5, subtract 3 is 2. So our first term is 2. A sub 2, our second term, would equal, we replace n with 2. Would equal 5 times 2, subtract 3, that's 10, subtract 3 is 7. Keep doing this. A sub 3, our third term, would be 5 times 3, subtract 3, that's 15, subtract 3 is 12. A sub 4, our fourth term, would be 5 times 4, subtract 3, that's 20, subtract 3 is 17. And a sub 5, our fifth term, would be 5 times 5, which is 25, subtract 3 is 22. Write the first 5 terms, or first 5 terms are 2, 7, 12, 17, and 22. We could check that by looking at the calculator. I've keyed in y equals 5x minus 3. And if we look at the table of values, right, so our x column, that's the number of the term, so our first term, and its value would be 2, second term 7, third term 12, fourth, and fifth. So we simply check that using the calculator. Number 2, a sub n is equal to 2 to the n power. So our first term, A1, would equal 2 to the first, which is simply 2. Our second term, A2, would equal 2 to the second, which is 4. Our third term, A sub 3, would equal 2 to the third, which is 8. Continue, A to the sub 4. Our fourth term would be 2 to the fourth, 16. And our fifth term, A sub 5, would equal 2 to the fifth, which is 32. So our first 5 terms here are 2, 4, 8, 16, and 32. And again, we could go to the calculator if we wanted, go to y equals, and key in 2 to the x, and look at our table of values. There we have 2, 4, 8, 16, 32. Number 3, a sub n is equal to negative 1 raised to the n power divided by n. Our first term, replacing n with 1, so that would be negative 1 to the first over 1. That's negative 1 over 1, which is negative 1. A sub 2, our second term, is negative 1 raised to the second divided by 2. Negative 1 squared is 1, positive 1, over 2 is simply 1/2. A sub 3, our third term, would be negative 1 raised to the third power divided by 3. Negative 1 to the third is negative 1. Divided by 3, we leave as negative 1/3. Our fourth term, a sub 4, would equal negative 1 to the fourth power divided by 4. Negative 1 to the fourth. If it's an even power, it's going to be positive. So it's positive 1/4. And a sub 5, our fifth term, would be negative 1 to the fifth power divided by 5. So that's negative 1 over 5. So our 5 terms here, negative 1, 1/2, negative 1/3, 1/4, negative 1/5. And see how our negative and positive alternate. Negative, positive, negative, positive, negative. Next, page 2. Writing rules for sequences. Okay. Sometimes this can be tricky. Write the next term in the sequence and write an algebraic expression that represents a sub n. Okay, so we want the next term in the sequence and an algebraic expression. Okay, so our first term is 10. Our second term is 20. I'm going to put a 1, 2, 3, 4, and we want to figure out what the fifth term is. How can we express 10 in terms of our first term? Well, let's see. If I think of this as 1 times 10 equals 10, right? And then is 2 times 10 20? Yes. 3 times 10 is 30. 4 times 10 is 40. 5 times 10 is 50. So our next term is 50. So a sub n is equal to 10 times n. 10 times 1 was 10. 10 times 2 is 20. 10 times 3 is 30, and so on. So this is our algebraic expression, 10n. A sub n equals 10n. And the next term in the sequence is 50. Let's look at number 2. Remember, this is the first term, okay? This is my first term, so put a 1 above the negative 2. The second term, my third term, my fourth term. So these are our n values. N equals 1, 2, 3, then 4. Okay, let's see. 1 times negative 2 would give me negative 2. Is 2 times negative 2 negative 4? Yes. 3 times -2, -6? Yes. 4 times -2 is -8, so our next term would be 5 times -2, which is -10. So a sub n equals -2n. Right? What do you have to do to 1 to get -2? Well, you can think of, oh, if I subtract 3. But then if I take 2 and subtract 3, no, that doesn't give me -4. 1 times -2 would result in -2. 2 times -2 would result in -4. 3 times -2 is -6. So that's your pattern. That's your expression. Number 3. N equals. This is our first term, our second, our third, our fourth. Well, 1 times 10 is 10. But is 2 times 10 100? No. What do we have going on here? Oh, let's see. If I take 10 and raise it to the first power, that will give me 10. 10 to the second, right? 10 to the second is 100. 10 to the third is 1,000. 10 to the fourth is 10,000, and 10 to the fifth would be 100,000. So our next term is 100,000. And our expression is a sub n equals 10 to the n. Number 4, 2, 3, 4, 5. We have 1 over 5, 1 over 10, 1 over 15, 1 over 20. Okay, so this looks like if I take 1 and times it by 5, that'll get me 5. If I take 2, multiply by 5, that'll give me 10. All right, so these are multiples of 5 here. So our expression is a sub n equals 1 over 5n. 5 times 2, 10. 5 times 3, 15. 5 times 4, 20. So our next term would be 1 over 5 times 5, which is 25. So 1 over 25 is our next term. And our expression, a sub n equals 1 over 5n. Next, 1, 2, 3, 4. Okay, getting more trickier. So our first term is 3 over 4. If I multiply 1 by 3 to get 3, can I multiply 2 by 3 to get the 4? No. How about if we add? If we take 1 and add 2 to it, we get 3. If I take 2 and add 2 to it, we get 4. Okay, so that's working. So if we add 2 in our numerator, so in other words, if we take n and add 2, that'll get us our numerator. Now how about our denominator? If I take 1, add 3 to it, I get 4. If I take 2, add 3 to it, I get 5. Okay, so now we add 3 in our denominator. So n plus 2 is our numerator, n plus 3 our denominator. So this is our rule. A sub n equals n plus 2 over n plus 3. And our fifth term here would be 5 plus 2, which is 7, over 5 plus 3, which is 8. So that would be 7/8. Number 6. All right, I'm going to write my ends down here because I don't have room at the above. 1, 2, 3, 4. Oh, well, that was nice. So I know our denominator is simply n. Now our numerator, let's see. If I take 1, add 5, I'll get 6. Take 2, add 5, I'll get 7. So there we have it, is n plus 5. So our rule is a sub n equals n plus 5 over n. What's our fifth term here? Well, if we want n sub 5, we have simply 5 plus 5, which is 10, over 5, which we can leave as 10 over 5, or we could reduce to 2. Now, terms of some sequences can be computed from the previous term. If this is the case, the sequence is called recursive. If you are given a recursive sequence, you will be given the first term, a sub n, and then a formula to compute the other terms using the previous term. For example, we have a sub 1 equals 20. This is our first term. That's given to you. A sub n plus 1 is equal to a sub n plus 5. This formula is called the recursive definition. It means that the current term equals the previous plus 5, right? If we were to simply have, all right, if we have n, what would come before n? Well, n minus 1. What would come after n? N plus 1. And what would come after n plus 1? N plus 2, right? So if we are focused on a sub n plus 1, if n plus 1 is the current term, what came before it is n. And that's what we have here. The current term is equal to the previous plus 5. To determine the second term in the above example, a sub 2, let n equal 1. In the recursive definition, the second term equals the first term plus 5, right? The second term would equal the previous one, which would be the first term plus 5. So we have a sub 1 plus 1 is equal to a1 plus 5. A2 equals, well, A1 was 20. 20 plus 5 is 25. To determine the third term, A3, let n equal 2 in the recursive definition. Then we have A sub 2 plus 1 is equal to A sub 2 plus 5. And A sub 2, our second term, is 25. So that's 25 plus 5, which is 30. To determine the fourth term, a sub 4, let n equal 3 in the recursive definition. So a sub 3 plus 1, right, and going back up here, putting 3 plus 1, is equal to a sub 3, that's the previous term, plus 5. And the previous term, or a sub 3, is 30. 30 plus 5 is equal to 35. Now write the first 4 terms of the above sequence. Our first term was given to us, that's 20. Our second term was 25, then 30, and 35. Type the starting value and press enter. Oh, sorry. To use a graphing calculator to list the terms of a recursive sequence, type the starting value and press enter. Use the answer key as the a sub n minus 1 in the formula to generate the sequence and press enter. Now simply press enter to create successive terms of the sequence. If you don't have a calculator with you at home, then we'll revisit this in class tomorrow. List the first 5 terms. All right, listing the first 5. This is the first term. I'll put that at the bottom so we don't forget. The first term is given to us. I'm reading this as a sub n plus 1 is equal to 2 times a sub n. Or the current term, okay, the current term is equal to 2 times the previous term. So a sub 2, which would equal a sub 1 plus 1, is equal to 2 times a sub 1. And I simply like thinking of it as the current equals twice the previous. So in that case, a sub 2 is going to equal twice the previous, which was 2. So that's 4. A sub 3, the current term, will equal twice the previous. And 2 times the previous term is 4. That's 8. Our fourth term, a sub 4, would equal 2 times the previous. And the previous term was 8. So 2 times 8 is 16. And I have to squeeze in one more. The fifth term, a sub 5, is equal to 2 times the previous, which was 16. So 2 times 16 is 32. So here are our 5 terms: 2, 4, 8, 16, and 32. The next one. A sub 1 equals 81. A sub n is equal to 1/3 a sub n minus 1. Right? Remember, if I go back, a sub n, if a sub n is the current term, then what came before it was n minus 1. So we have here our current term equals 1/3 the previous. Our first term is 81. Our second term is going to equal 1/3 of our previous term. So 1/3 of 81, which is 27. Our third term is 1/3 the previous term. The previous term is 27. 1/3 of 27 is 9. Our fourth term, a sub 4, is going to equal 1/3 the previous term, which was 9. And 1/3 of 9 is 3. And our fifth term, 1/3 the previous. 1/3 of 3 is 1. And let's make sure we write these correctly. All right, our first term was 81. So we have 81, then 27, 9, 3, and 1. This concludes tonight's video.